The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporland.com and navigate to the Resource Center. Parker Sporland, leading the charge.
Do that.
No, he didn't. He said something really nice to me today. I'll have to share it with you after because I don't
believe that, but
Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel and Kevin Compass. And hey, happy Good Friday. How's your Good Friday going?
Not too bad. Just got back from Atlanta.
Yeah, how was that?
This time it wasn't too bad.
Yeah,
I was in Augusta, Georgia, so it wasn't.
How's that versus Atlanta?
Still the hood.
Really?
It was
in the ghetto.
Oh yeah, like 3:00 in the morning when I was leaving, going to the gym. There's some lady throwing some dude's clothes off the 3rd floor of a balcony, and I'm like, "Where the fuck are we at?" I'm like, and we're at a Hilton. And it doesn't matter where you are. Like next to every Hilton, there's some like motel with the rooms on the outside. That's how you know you're in the hood or like the ghetto when you got the rooms on the outside. But like next to every store is one of those. So it's okay. There's like homeless people like wheeling around shopping carts everywhere. I'm like, this is not going to end good. I go, I guess we're leaving all of our tools at the store.
I actually have a new rule. Whenever I'm booking a hotel, I see how far it is away from a strip club. Because too many times, like, I'm like, oh, yeah, that looks like a good hotel. It's not that expensive. And then all of a sudden, shenanigans ensue, or the hotel that I go to has ended up being rented out by the hour. And so I'm like, it just doesn't end out well.
Usually I look at the reviews, and it's like, my car got broken into. It's okay, we're not staying over here. And and then we were in rental car hell. Like, the rental car, like, the 3rd day, like, the hatch decided to stop working. So it is held back down with a ratchet strap. We're just like, come on. Like, I got all these pack outs in there, and we're driving back from one store to another, and we're gonna lose all these pack outs.
And one of the things, so when we went down to Georgia for one of the events, I remember someone telling me, is like, make sure that you don't have anything in your back seat. And I'm like, why? He's because they'll come up and smash your shit out and grab whatever bag and stuff is in the back. And I'm just like, remember shoving everything in the damn trunk. It's like, I got nothing in the car.
Yeah, it was eventful. So I was doing RTU controls startup / upgrades. It was a mildly boring week of just trimming out wires and testing sensors and validating stuff. So mildly boring, but I don't know. Waiting for downloads and waiting for OEMs to program stuff, and then fixing OEM wiring and stuff that, like, you would think when they make the same unit 500 times over, they would not screw up as much as they do, but they do.
Yeah, if we can plan it out better, I'm going to have Matt on there to talk about some of that stuff. Yeah.
But yeah, so other than that, like, it was a pretty chill week, a lot of chaos back home, and come back to that. But yeah, and then I was working on quotes all day today, which is the most boring thing in the entire world.
Yeah, I flew out. I was home Monday. I don't even know what I did. In traveling so much, everything's been a blur. But Monday, Tuesday, I was up in your area. It was like an hour and a half away from your house. I had a meeting with the contractor up there, and I don't know, we're probably going to get to do some work up there with them and all over the place. And, I got my package in. I saw yours, and so I finally got mine in. I haven't gotten to play with it yet. It literally just got to the front door. Oh, no. Please tell me you can't hear that.
I can't hear anything.
All right, good. Because I must have not shared my audio. I had my Danfoss controller running in the background, and all of a sudden it goes, like my computer's going to die. So, I don't know. We're going to talk about, transducers and sensor calibration, right?
Basic sensor troubleshooting and calibration and checking inputs and stuff. Just like basic stuff where a lot of guys have been missing stuff. And we're going to go over some like 0 to 10 volt stuff for inputs and outputs. So we're going to start off with the basics, guys. We're going to start off with a thermistor. So like you would see on a Copeland system, you're going to see a 0 to 10. I'm sorry, a 10,000 ohm.
We want to do that one first?
Yeah, we'll do that first.
Okay.
You're going to see a 10,000 ohm NTC 2K sensor.
10K.
10K.
10K type 2.
10K type 2. Jesus.
So let me just elaborate on that a little bit, because there are different 10K sensors, and that's what makes this kind of hokey. So you have the 10K2, which is on the CPC, which is on microthermal, and then you also have 10K type 3. Now, whenever you hear the first number, the 10K, that typically represents the amount of ohms at 77 degrees if it's an NTC, right? So no matter if you measure, if you have it in at 77 degrees, you will get 10,000 ohms at that temperature, right? But the problem is that the curve changes. So like down here at 30, 29 degrees on the 10K2, you have 35,573. And then if we go back to the other one, wrong way. And if we go to the other one at 29, it's 31,878. So it's still 10,000 ohms at 77 degrees. But then when you start getting like lower in temperature, the curve, basically the curve is different. So that's the one thing with sensors. Sensors are not linear. There's not, for every 1 degree, it's X amount of resistance of rise. They're not linear. So let me just express that, because what we're going to look at later, we can do some stuff with some pressure transducers because those are linear. These ones are not.
Now, the NTC part is negative temperature coefficient. So meaning as it gets colder, the ohms go up. As it gets warmer, the ohms go down. Now, you could have sensors that are PTCs also that are the opposite.
Yeah.
That as it gets colder, the ohms go down. So it just depends on what it is. Now, Copeland systems, microthermal, some Danfoss uses some random 10K sensors.
Some Sporlan stuff does too.
Sporlan stuff, SE3s are all 10Ks. So a lot of those sensors are interchangeable. So
unless you have, if you ever seen those dick cells that you can see at like United has a one that's, or a couple of them, a couple different models that come in a package. It's usually a silver sensor with a black lead. Those ones are the 10K3. And someone lied to me the one time. They're like, oh yeah, you can use a CPC sensor. And then I did. And then I'm like, I'm measuring it, and as the temperature's going down, it's not measuring the same temperature. And I'm like, what the hell? And then that's when I come to the realization. I was like, oh, it's a different 10K sensor.
Yes. You could also change those ones, the United ones, to use those XR70 or the XR60 CXs or whatever they are.
Yeah.
You could change those to Danfoss sensors too.
You can.
Yeah.
But if you have multiple sensors, then you have to change out all the sensors. You can't just change out one input.
The Gutners you can. You could change it to run off of a Danfoss sensor. You could just do the fan input if you want to.
Gotcha.
As you're checking these, so these are the easiest thing in the world to check. So what you're going to want to do is disconnect it from the board. You're checking, and you're going to want to take your meter and put it on ohms, and you're going to want to check across signal and ground of the sensor. So you have the two wires you want to check. Okay. You're going to want to check it, and you're going to want to compare your ohms to what the chart is.
Don't have your hands on it. Don't have
Correct.
your hands actually on the wires.
I usually leave it in the plug and then pull it off the board and then check it.
Yeah. The other thing is too, you want to check it at both ranges because you don't know if the guy that was there before you basically just put a different sensor in, like I was saying with a 10K2 and 10K3. So check it at room temperature, but then also check it on the lower end in the ice water.
I usually start with checking it at the board just to see what it is.
Oh, okay.
If it's reading all funky numbers or not reading at all, I start at the board and check it there. And if I have no ohms and say it's open or if it's shorted, then I will move on to the case and check it. And then I will isolate it at the case and check a sensor there. If I have ohms and it's close to what the case temperature is, then I know I have a cable issue. So at that point, I will disconnect the cable. I will check the sensor again. If the sensor is good, I will twist the cable together and I will go back upstairs in the rack room or wherever the board is, and I will put my meter on ohms and I will check that. And I should have a closed signal. I should have zero ohms, closed signal at that board point with it disconnected. And that would tell you your wire's good. And at that point, you're going to resplice your connections or you're going to recheck it and then try it again. You still could have a bad cable. Some mouse got it, bit it.
Sometimes with the sensor disconnected and disconnected from the board, right? This is all done with the sensor disconnected from the board. Molex plugged, pulled out, whatever. You also want to check from leg to leg and see if it's shorted because you could, like he said, you could have a mouse that chewed through and you got a strand, just shorten that thing out, or someone was tugging on the damn thing. The other thing that you can do is short the two ends together at the other end and then measure the resistance. And like typically you'll have there's like a power factor that it typically has that you need a power factor meter for, but like you'll get accustomed to. So if let's just say the wire that they're using is 300 foot and you've measured that before and that wire has, I don't know, 1 ohm of resistance across it from a 300 foot run. Now you'll know, have that for reference and you're like, well, if that happens again, but it's a greater resistance, then you know you have something going on within that wire, maybe another junction within the roof.
So that is a huge problem with Danfoss because with Danfoss, you have 1,000 ohm at 70-degree sensors, 77-degree sensors. With Copeland and Microthermal, they're 10,000 ohms at 77 degrees. So you have a lot less room on a Danfoss sensor where that actual added resistance from that wire run is going to cause an issue. And I've seen it where 300-foot runs of Danfoss sensors, they're off like 5-6 degrees, the whole row. So you'll have to go through. That's why you calibrate Danfoss stuff so much more. Like I never put offsets in CPC stuff.
If you do get some kind of issue or someone was just monkeying with a bad connection, whatever.
Yeah.
Side note. So all these charts that I'm showing here came from a website called BAPI, B-A-P-I. I'm sure, I swear to God, I didn't make that up. BAPI makes sensors and transducers for everybody, literally everybody. So they have to be able to make, like this one that I'm showing right now is the PT1000. This is the Danfoss sensor. So this one's at 1,000 ohms at 32 degrees.
Yeah. So
ohms, 32 degrees. Yep. There we go.
So you'll see like that Danfoss sensor has far less wiggle room with the impedance of the wire. So that means on longer runs with Danfoss, you should probably be pulling 18 gauge instead of 22. But again, that's expensive. And is it customer spec? If the customer spec and only paying for 22, they're not getting 18. 18s are probably what it needs to reduce that resistance across the line. It just is what it is.
You can see right here, if you go from let's see, 940 ohms to 944, so just 4 ohms, you're basically increasing that by 2 degrees, right?
Yeah, that's why on case controllers, with Danfoss, you never have to do offsets.
It's so damn close.
It's so close, and it's generally the sensor wire is landed right on the board.
Yeah. So back to the BAPI thing real quick. So let me just finish this up. So BAPI, B-A-P-I. If you go there, if you just go to Google and just go BAPI and then 10K type 3 and then type in temperature resistance chart, 99% of the time that thing will come up and you'll be able to find it. So you'll see like this one right here. I have this one up for the Danfoss one, PT1000. 10K2, we just rattled off all the manufacturers that do that one. 10K3, I don't know who else uses these besides those Dixel like self-contained case controllers.
That's pretty much the only place I've ever seen them.
Okay.
They may be in different like manufactured stuff.
No, I got you. And then you have the 2K sensors, which are big on the Sporlan superheat controllers, Sporlan subcooler controllers, K2 Novar, all the Novar stuff that goes to the
1081s and the 521s.
The Minio boards, yeah. They usually use, it's funny because a lot of times they do use them for the subcooler. So if you don't have a Novar sensor and you can't find something, you can use a K2 sensor. Sporlan one. I don't understand why they all don't have a long longevity. I used to carry a crap ton of these when I didn't have soft hands.
The 2Ks fail more than any of them. Like the Sporlan 3Ks fail way less. It's just 2K sensors. I've never had good luck with any of them. The Novar ones, the Sporlan ones, the 3K Sporlan ones last way longer.
Yeah, for sure. I don't know if it's because they're conical. Like these are the ones, the surface one. So it's a flat on the bottom, and then so it's like a half moon or whatever. But once again, so you can see 3K at 77 ohms. This one's 2K at 77 ohms. And then, we didn't get the transducers yet, but yeah.
I think the 2Ks fail more because they're usually in those wells, and I think moisture builds up in the wells and pulls on the wire.
Yeah, for sure.
And then the 3Ks, you end up replacing them. They don't fit in the well, so then they don't fail.
Strap them right to the pipe then at that point.
But I do. I just use a stainless zip tie.
Yeah. But yeah, so like with sensors, there's not that much to check. You see what it is right at the system itself, and you can see it.
Well, side note, I will say this. Make sure that your meter reads a high enough ohm reading. Not all Fluke meters will read over 10,000 ohms. Like a lot of their HVAC meters, like I think the 116 may, but like the 902, like FCs, like the clamp ones, generally do not read over 10,000 ohms. So if you're trying to check sensors, that meter may not read over that. I use a Fluke 179. That's generally what I have guys get when they're working, like doing EMS work. It's a great all-around meter. It could read 4 to 20 milliamps. It could read high resistance. It does good with everything we do.
Yeah, I forget what I usually get the combo set where you have for service anyway, like the small Fluke meter and the amp clamp that comes together. Amp clamp is going to measure that high resistance, but the Fluke meter will. But yeah, like a lot of the field pieces, like the resistance doesn't go high enough. Like like PT1000, yeah, definitely. But if you're talking about something like the 10K3 or the 10K2, a lot of times it doesn't have the resistance value that it needs. You know what I mean?
So yeah, you're gonna have a tough time troubleshooting this properly. And then the same thing when it comes to when you're doing some like 4 to 20 milliamp stuff. A lot of meters don't have the ability to read 4 to 20 milliamps. So I don't know if the field pieces can read milliamps.
No.
Yeah, so the field pieces can't read milliamps.
Well, this amp clamp one doesn't. Maybe the other one that's not an amp clamp does.
Oh,
you can't. Go ahead.
Yeah, maybe not all of them, but I don't know. Like Fluke makes a really nice process meter. I can't afford it, but
yeah, it's $689.
I know. I keep like getting to the point where there's been a couple times I'm like, I need this.
But how many times are you really going to use that?
It's but it's got a signal generator built into it.
Oh my god! Yeah, but I can buy a signal generator for.
I know, but like,
$60.
How many times were you like, I got to unwire this to read 4 to 20 milliamps? It'd be so much more convenient to just clamp it on there.
Agreed.
There's been a couple times where this is worth $600.
I'm gonna have Bob buy
for the
one.
company to buy.
Bob buy one.
Yeah.
So you want to talk about pressure transducers now?
Okay, let's go to pressure transducers. Now, pressure transducers, guys. So they come in all shapes and flavors and sizes. If you're talking Copeland stuff, it's going to be 0.5 to 4.5 for their general can stuff. And it could be 0 to 100, 0 to 200, 0 to 500, 0 to 650, 0 to 1,000, 0 to 2,000. All the ranges are on there. I don't know why everybody started doing this when they started ordering the transducers. I don't know why they're stamped now with like laser and etching. I absolutely despise it because I can't see it, and it's every one of the manufacturers. So I take a marker to them and go over the laser etching, and you could see the pressures and your voltages.
Yeah, 'cause you need not just the voltage of the signal, or the signal, I should say, because it could be in voltage, it could be voltage drop, or it could be milliamps, right?
Yep.
But you also need to know the resolution as far as like the pressure, right? So what he was talking about before, 0 to 100, 0 to 200, 0 to 400, 0 to 650, 0 to 2000, whatever. And then the last thing that you need is the power requirements. Some pressure transducers can go as low as X voltage, and then they have a wider range. Or, what Novar ones have a pretty wide range. This can go all the way up to 36 volts from like a minimum of 6 to 36 or some shit like that. Whereas CPC transducers usually going to be 5 or 12 volt.
Yeah, it's been a while since I've seen a 12 volt CPC transducer. That was more like RMCC era.
Yeah, no, I but remember I'm old. And then you also have, I think, the other ones that have a fairly high, like
Danfoss,
12
volts.
Yeah, and like I said, some of them have a little bit wider range. It usually just has, I think the minimum voltage typically is set with what the output range is, what it seems like to me. You know what I mean? So you never want to go like on a Hansen rod. If you're doing a Hansen rod that's like 1 to 6, you got to power that up with 12 volts, because otherwise it won't ever be able to put that voltage out if you're supplying it with 5.
Correct.
So we need the power requirements to power it up. We need what the range is as far as the pressure, 0 to whatever. And then we also need to know the voltage or current milliamps for the range, because otherwise one of those things are wrong, and then, it won't read right. You know what I mean?
Now let's go over a basic, we'll say like a Copeland style, Danfoss style, where we're reading DC voltage at an input. So what we're going to do is we're going to take 5 or 12 volts, whatever's powering that transducer. It's going to go into the transducer. This is a 3-wire connection. You got power in, you got a ground wire, and you got power out, meaning your signal input. Power out is going to be your signal input. So what you're going to do is you're going to find all 3 of these wires on the board. And I always start like this. I go from the power feeding the transducer, meaning your 5 or 12 volts. I will take that and I will go to ground on the board. The sensor or the transducer ground, meaning that the signal ground, I will go there and I will check my voltage. You should have whatever that transducer is supposed to be supplied with. If it's 5 volts, it should be 5 volts. 4.9 is like the lowest, 4.8-ish. And then same thing if it's 12. You want to have 12 volts there, 11.98, whatever, 12.1, whatever.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
You shouldn't have 15 volts there. You shouldn't have 10 volts. That's going to affect it. So you want to make sure you have that incoming voltage there. Okay. Now you want to take your meter and go from ground to the signal wire, which is generally a white wire. Not all the time, because there's been a bunch of this got my ass last year. Some transducers, they switched some cables on and caused some issues. So you want to find that signal wire, and you want to go from ground to signal. You should have a DC signal on there. It's going to be linear from whatever it is. If it's 0 to 100 psi and it's a 0.5 to 4.5 transducer, at 0.5 you're going to be at 0 psi. At 0.5 volts DC, it would read 0 psi on the controller. At 4.5 volts DC, you should be at 100 PSI. And you could linearly scale that through this. Now, like Copeland has a chart, so you don't really have to do this. Copeland has a chart where it'll show. Danfoss has a chart where you could look at this and say, okay, I'm at 3.5 volts. I should be on a 200-pound transducer. I should, because nobody really uses 100 PSI ones anymore. You should be at 150 pounds, give or take a PSI or two, wherever it is. You should be relatively close to that.
And that's what I made. This is actually they have these tools on your phone called the linear interpolator. There's linear interpolator that's on Android, and then interpolation master, I think it's called, on the iPhone. And you can put in these values. Like, it'll ask you for a start value. You always put your voltage on your left because it works better that way. So I would start by saying, okay, I'm putting 0.5, and then on the other axes, it'll say, okay, what are we reading on that? So, okay, so 0 would equal 0.5, and then put the end rating in, which at the very bottom, which is 4.5 to 200. Then you can put your mystery voltage of what you're getting at the board, and it should spit out a pressure of where it should be based on that interpolation of those numbers. Like I said, so sensors are not linear, pressure transducers definitely are. So that, like I said, that's what I did here. I basically made my own interpolation master on an Excel spreadsheet. So you can see here, I put 0 to 200, 0 to 500, and 0 to 1,000. So obviously 2.5 is just about right in the middle. So that's going to be where it's going to be 500 pounds in the middle for 0 to 1,000, so on and so forth. But these other numbers, like if you're getting an odd number and it's not making any sense, maybe someone has an offset in the controller or something along those lines. That
is the next point I go to. If I see one and I'm checking it and it's 3.5 and it's not reading 150, guess what? I'm going right to the setup of that. Is it set up and scaled properly? Is it set to the right pressure? Does somebody have an offset in there? Because I'm going to tell you this right now. Generally, transducers either read right or they read way off. They're not 3 to 5 pounds off. That 3 to 5 pounds is your gauges. And to be honest, I trust most transducers more than most gauges. If you're checking transducers with a needle gauge, you're doing it wrong.
If you have incremental a gauge that's one like increments of 1, I'm okay. If you don't have the money to afford a digital set of gauges,
it's
as long as the increments
around in a service truck, hang in there. Those
I'm
gauges
just saying
are no longer
better.
accurate.
Okay, my point is that I've had guys just recently in training. They're like, they brought out their 410A gauges and were trying to check superheat or check to see if a pressure transducer is right on something that, I don't know, every increment is 5 psi. How the hell do you check for accuracy if your gauge is, there's no way to do that with a set of 410A gauge. If you have an analog gauge that has increments for every single one, I'd be more apt to trust that if you don't have access to a physical, like a testo or something. But that's when you do the cost analysis. You can get a digital gauge off of, the place that delivers stuff to your house for $50. You know what I mean?
Those Elko ones that I had for a while, like those Chinese knockoffs, did great. Yeah, they drifted when they got cold, but like for the most part, like when you were checking stuff, like for checking transducers, they were great. So I don't trust them if they're not checked with another transducer. Like you need to check that. Now, as we're looking at this on this multi-flex board, you're going to notice the black is hooked to 0 volts. 0 volts is ground. Ground on where the shield is completely different. That's a shielded ground, meaning like that is physical ground of the actual like rack or cabinet or wherever it is. Now that black goes to 0 volts. Danfoss calls it signal and ground. Microthermal calls it signal and ground. Copeland calls it signal and 0 volts. So that's where you want to check it. And again, you could check the transducer with it plugged in, but I also unplug the signal wires. You need to leave the 12 volts or 5 volts plugged in to check it again. If you do it with the plug on, the 5 or 12 volts has to remain in.
Yeah, the other thing about this is fine. So if you notice, like black usually in high voltage, right? Usually black is equated to hot, and it seems like the standard for low voltage is that black is typically a negative or common, if you will. And then if you are checking that stuff here, you just have a clip right here. One of the things that you should check into right here is within this actual plug right here, there are wires that with small screws that can become loose that give you erratic temperatures. And I have something I can show. So go ahead.
Oh man, that caused so many issues on a CO2 rack up here. I don't even know how many service calls on a 326 that caused. And finally we found it by wiggling the top of it, and the terminals were loose.
It might be a pain in the ass to do on a PM, but I recommend always just going literally, like if they've never been done, and usually they've never been done.
Pain in the ass to take apart.
It is a pain. All right, so I'm hold on. Let me.
But here's the thing: I don't really want people taking them apart because, like, you risk messing them up.
How?
If somebody bends it or fucks up an input on the transducer, risky.
All right.
Risky business.
So here's the plug right here. All right, I took the screw entirely out. If you look, there's all your terminals at the bottom there. And then there's a small outline right towards the top. And then you can pop this screwdriver in there and pull it out. And you see there's very small screw holes right there. So that's where those little small little screws that are just about the size of glasses ones, that's where those can actually end up getting loose and then causing you to have a bad or erratic connection.
And startup, I find them wired wrong all the time.
Yes, sir.
So that's another big one with those. They get wired wrong all the time. So that's another one to be aware of, is making sure they're wired properly and not wired wrong. Now, with the Danfoss stuff, your scaling is going to be a little bit different. So Danfoss, is Danfoss 4.5 to 5?
No, 1 to
6. 4.5? It's 1 to 6. Yeah, I forget. It's 1 to 6.
You see it?
Yep. So Danfoss is 1 to 6. Okay. On all of them?
Most of them.
You sure? I thought the AKC, like the 0 to 200s, are 0.5 to 4.5. Or they're 0.5. I don't remember. My head hurts.
Which ones are you referring to?
Like the normal, like rack ones, not the plug, not the ones with the fixed plug.
I know which number is that. That's AK.
Yeah, you think I remember all these?
No, I'm pretty sure it's not. I'm pretty sure it's
it may be one. It may be 1 to 6.
AK is an AKS 32, and then whatever the pressure is, right?
Yeah.
Pressure transmitter. Blah blah blah. All right, here. Blah 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 blah. All right, so here, red is power supply. White is pot. Oh, so this one makes sense.
Yeah.
Accuracy, blah blah blah.
And it's 1 to 5.
Is it really?
Hey, look, right to the right.
Mother of yeah.
See, I knew 1 to 6 wasn't right on that one.
No, but it is on the pluggy ones. On
Yeah.
these ones, it's not.
Bastards, making them different.
Yeah, why would you do that? CPC's been 0.5 to 4.5 forever, and Danfoss has been 1 to 6. Now all of a sudden, hey, we're going to throw in a wrench.
Yeah, this is a classic example of make sure that you actually check this.
Yeah, I agree.
And then, like I said, like the Copeland and microthermal transducers, the Sporlan ones, they went to laser etching on all those. So take a marker and just color it with a marker and wipe it with your finger, and it will take that laser etching and make it black so you can actually read it, because I can't read it. So
see, now here's another one that's going to throw you off. Look at this one. These are the older ones that are on all the old racks. Now you can make it out.
That's 1 to 6, yeah.
Yeah, 1 to 6. So it's that. Why?
Because that's why.
I hate you. I hate you.
All right. Now, check it on Danfoss board. Same thing. Check it with it plugged in, and then go ahead and unplug it and check it, leaving the power wire plugged in and powered. Look at that one. That one's probably like a random one. Like it's just
This one's 0 to 10. It's a D plus one.
Yeah. Because they can.
Because they can.
Yeah. So that's another one just to watch out for. Now, when we get into some other stuff, when we start getting into like more Corel stuff and RDM, now you start seeing 4 to 20 milliamps. 4 to 20 milliamp signals are a little bit more standard in industrial stuff.
Even HVAC controls, anything J's control, it seems like 4 to 20 because it's more accurate if you really think about it.
It's more accurate, and it's a lot of life safety stuff is 4 to 20 milliamps because there's a safety factor built into it. Like it's not 0 to 10 or 0 to 5, because if you're looking at a 0 to 10 or 0 to 5 volt signal at 0, you may not know if the sensor's ever bad.
Agreed.
So the input. So that's why 4 to 20 milliamps, you'll see a lot more on life safety stuff, leak detectors, stuff like that. So the
other milliamps is basically used to power this thing. And that's
Correct.
The other reason why.
And then the other benefit is it's one less wire.
Yeah.
So it's a 2-wire signal instead of a 3-wire signal.
Go ahead, keep talking.
So standard 4 to 20 milliamps, you're going to have a power supply. You could have a master power supply for the rack supplying everything that's 4 to 20 milliamps in here. So all your transducers can come off of it. So the way it's going to work is you're going to have a positive wire on the transducer going from the power supply. The negative of the power supply has to be tied to the negative of the board. Please, God, please make sure you have the phasing right on whatever device is powering this and the device that's powering the board. Meaning, like, if you have a DC power supply powering the board, make sure the phases are like the positive and negative aren't flipped. Same thing on a train. If it's a transformer, make sure the hot is the hot.
What will happen, Kevin?
It'll start smoldering and all the smoke will start popping out.
You don't like that?
No. So it has to be phased properly and on the same type of power supply. So now go back to that thing. Where'd you go? You're on the wrong screen.
I'm on the wrong screen.
You took the 4 to 20 milliamp away.
Sorry. I know what I did. Sorry.
Yeah.
Go ahead. Continue.
So you have your power supply, then you have your input. Now, the outlet of the transducer, meaning your voltage out, which is going to be your negative, is going to go to the signal in of the device. So the positive side of the device. Now, the bad part about this is you can't just put your meter on common and positive of whatever device it is. Now the whole thing's gone.
Yeah,
Jamie, you're fired.
I need 3 screens now. That's what I need to do because
I have 3 screens. You know 3 screens? Why don't you have 3
I have 3 screens, but the other one's my MT stuff. Shut up.
So you have your device here. Now, this is where it gets complicated, and a lot of guys quit switching the screen.
It's still on that screen. Stop it. I'm looking for something. Go ahead.
Really messing up my ADD. So what you have to do is end up wiring your meter in series with this signal. So on a fluke meter, you have essentially 3 or 4 plugs on there if you have a proper meter that reads milliamps. So what you do is you have a common plug generally that reads on all of them. Then you have a milliamp plug. Okay. You're going to move your red lead of your meter into the milliamp plug. Now you're going to take your red lead and your black lead, and you're going to wire it in series with the voltage out going to the input. So where it says V minus on there, where he has it on the screen, and it goes to plus on there, you're going to wire your meter in series with this. You're going to take off the wire off the board. And generally I use the alligator, like fluke, like the needle grip ones, where you got to put your 2 fingers in there and peel them back, and it grabs the wire. Works real well with it. And then you end up wiring a wire in there and just wiring them both in series with it, and then set your meter on milliamps and then the proper scale, and then you can read the signal. See, that's a pain in the ass. And that's
but you still haven't bought the $600 or $700 meter though.
I have not, because we don't do a lot of zero or milliamp work. I'm starting to get more into it because I'm starting to see it on other stuff, but that's going to give you your reading from the sensor. Now, as you're reading your milliamps, 4 milliamps is going to be 0 volts. If you have under 4 milliamps, you got a problem with the power supply, or you got a problem with the transducer. If it's reading under 4 milliamps, you're going to get an alarm for a bad transducer, bad open transducer, whatever it's going to read, however that sensor set up. If it's reading over 20 milliamps, it's going to read an alarm for that. So on that scaling from like how he has it on there, so 0 to 200 at 4 milliamps is 0. At 20 milliamps, it's going to be 200 psi. So it's just like checking the 0 to 10 volts DC, except it's a little bit more steps because you have to wire your meter in series with it, and you have to set it up for milliamp control readings.
Yes. Yeah. So I'm just going to just bring this up here. See that. Blah, 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 blah. There you go. So whatever your instrument is, that's where basically your instruments are going to be your pressure transducer, but essentially just move that line over and just hook it up in series with it. That's it.
Yeah, and then also, if it's not reading anything, I did this in the beginning with that. If you put your meter leads in the wrong spots in that fluke meter and check voltage, it'll blow the fuse inside the meter. Like a fluke 179, if you put your meter leads in the wrong spot, say you put them on the left-hand spot instead of the right-hand, you were checking voltage, you blew the fuse in the meter.
See, so, my one meter that does do milliamps, it is a fluke, but it only has two leads, so it can do milliamps on either one.
Yeah, so like a 179, 178, one of those, they're all fused. So if you accidentally do that, like I always check it first with my meter leads. I just put them in the normal spot where it works for ohms, and then I'll stick them in the other spots where the milliamps are, so I could check and make sure the fuse is closed. Because you don't want to condemn something that's not bad because you blew the fuse 8 months ago and didn't remember.
Yeah, this is probably a better. Bango,
correct.
Not my picture. Not taking credit for it. Just wanted to. It's one thing I didn't have for today, so I'll fix that. But there you go. That's how you would hook it up, or unless you have the magic meter.
If you have the magic meter, you're super lucky because that thing's sweet because you could just clamp onto it like an amp clamp, and it gives you super accurate data.
What is it? Fluke milliamp. Oh, there it is. Fluke 77. Oh my God, the price inflation.
What is it now?
Holy shit. So this is like Granger, so it's probably a little bit less than what it has priced. Holy shit. I should have bought
You can't look at Granger prices though. They're like astronomically marked up. Yeah, okay. They added an extra $1,000 on there.
No, they didn't add maybe extra $600.
Yeah, that thing is pretty sweet. Now, a signal generator, guys, is something to have to check stuff. Like I have a $35 signal generator off Amazon. And it's battery powered, and it could also be powered from a power supply. I keep this thing because if you ever need a 0 to 10 volt signal for a condenser because some control system can't do 10 to 0 and it doesn't fail on, you can leave this thing with it plugged in and it'll be 10 volts for forever. Signal generator is a great tool to have. Now, if we're troubleshooting 10 volt DC outputs and 5 volt DC outputs to drive fans and stuff, pretty simple. You're going to have your output on the board and you're going to put your meter on DC volts. You're going to read across it from red to black. Red is going to be your positive. Black is going to be your negative. Red and black.
So that's the other thing too. Like you can actually put this directly to the input, but have your pressure transducer disconnected. And like this could be your pressure transducer. So if you suspect that the input could be bad, you can be like, all right, I know that 2.5 on a 0.5 to 4.5 pressure transducer that's ranged for 1,000 psi is 500 or 500 psi. I can put 2.5 volts on that and see, okay, is the controller in fact reading that? Because then that'll alleviate, okay, is it programmed wrong or does it have an offset? Because an offset will also throw it off. This goes down to the point, like you can do 2.51, 2.52. Like you can go up in small increments with this thing. So
just if it's don't put more than 8 volts on a multi-flex board.
Really?
Yeah, the max is 8 volts.
Is it really?
Yes. If you have a 0 to 10 volt input that you need to put on like a Copeland multiplex board or an input board, you need to have a voltage divider.
Oh, okay.
So it'll actually mess the board up. So you need a voltage divider. Danfoss, I believe, could take a 0 to 10 volt into an input.
I think it can.
Microthermal can definitely take a 0 to 10 volt to an input. When you're doing these, like when you're checking a DC, make sure it's phased properly. Make sure that the device you're going to, the transducer feeding that, is phased properly, meaning like the hot of the transducer is on the proper terminal and is the same terminal, the hot side, as the board. Because if you flip the transformer feeds, say for an IDCM, this is super common in the protocols. Somebody will change a board and they'll flip around the hot and the common on the IDCM. Super easy to do. It's a yellow and a blue wire. They'll flip them around. When you do that, you put 24 volts AC on the common of the signal input. So what ends up happening is it smokes the board point on the AO board for Copeland or Danfoss or Microthermal, whoever it is, because that common should have 0 volts on it. Now it has 24 volts and the hot has 10 volts or 5 volts. There's a voltage difference. So it smokes the input.
Here's that's another signal generator that they have out there that basically puts out your voltage as well as it puts out your voltage and you can power up the device without actually having hooked up. So you can power it up with X voltage, right? And see what the output voltage is or output milliamps.
I would have bought that one. That one's way nicer.
Man, I have such a hard time. I don't know if I'm just dumb. I have such a difficult time with that damn signal generator that I bought.
The one I have is like super easy. It's like super simple. It has a dial and a button you push for voltage or amps. It's like cheap, but it does a good job. And same thing with, you could also have outputs of 4 to 20 milliamps. So just like an input, you could also output another device 4 to 20 milliamps. And it's going to be checking. It's going to be the same exact way. You're wire your meter in parallel with it, that device that you're sending out 4 to 20 milliamps. So generally, I think Microthermal could do 4 to 20 milliamp outputs. I know RDM does. A lot of our stuff is going to be DC only.
Yeah, usually there's certain things that we put in a 250 ohm precision resistor to actually convert that back over to voltage. So like the MLD, no, which one's the one with the multi-port?
The IR, yeah. It's called everything. IRLDS. It's a back rack leak detector.
Yeah, basically the one with the multi-channel. So like it has this thing where it can send out the milliamps, but a lot of the controllers, Danfoss can't take 4 to 20 milliamps. CPC can't. Basically, they can tell what zone it's on based off of the voltage drop and then what the PPM reading is, because you basically use 2 inputs together. And so typically you put a precision 200, I think it's a 250 ohm precision resistor is usually when they put that when you wire that thing up.
It's 250 and 500. They both divide it differently. One makes it 2 to 10 volts and one makes it 0 to 5 volts. I always get it confused. I always got to look it up.
You have to do Ohm's law.
Yeah, that's how you figure it out, and it has to be a precision resistor. And I generally keep some in my truck because I do a lot of control work. So I will generally keep some resistors in my truck. I keep a pack of resistors off Amazon. I buy like a 10,000 pack for $10 to keep in my truck for when you need random resistors. Comes in handy, especially on service. If you're changing out leak detectors or doing random stuff where you need a 275 ohm resistor here, got that in my truck, or I can make it with a combo of other resistors. So that's one thing to keep in mind when you're doing some of this stuff. If you're doing some more control work, to keep that stuff in the truck. Got anything else?
Got nothing. I'm done.
All right. Let's wrap it up.
All right. I guess we'll talk to you guys next time. Have a great day.